Section 4.4 is going to be broken into two videos, but it's really just one day's lesson. And there's two objectives, number 8 and number 10. And it's really more of 10. Number 8 says find exact values of sine or cosine via a sketch, and then explain when we would use the theorems. These are the theorems from 4.3. We may not focus on those as much. It's more of the exact values is what we're talking about. Objective number 10 is very similar. This says find the exact sine, cosine, or tangent of a value on the unit circle and stated in radical format. So this section, basically no decimals are allowed. If there's something that is approximate, it must stay in radical format. So let's get started by looking at an activity related to it. Now in the first part of the chapter, we said if we go on a unit circle and we draw a ray of an angle that measures 45 degrees, we know that the ordered pair that would land me there, I could easily find it by doing the cosine of 45 degrees and then the sine of 45 degrees. And when you do that, you're going to get that it's a decimal approximately 707 and then again 0.707. Now these are approximate numbers. We need the exact values. I'm going to tell you right now the exact value is a radical. It's a square root and we need to find it. Let me show you how it's derived. First of all, recall that 45-degree angle is the same as pi over 4 radians. It's 1/4 of a pi. It's 1/4 of half of a circle. And if you look at this right triangle that's inscribed in the circle at 45 degrees, we can actually deduce, using the Pythagorean Theorem, what the actual order pairs are. Now, what we do know, if it's a 45-degree triangle, that these two base angles have to be congruent, which means these two side lengths have to be congruent. So we have an isosceles triangle. So what I'm going to do is actually call this side length x, and I'm going to call this side length also x. So I can use Pythagorean Theorem to figure out how long the legs are. A squared plus b squared equals c squared. Well, in this case, my a is going to be x squared, and my b is another x squared. And then set that equal to c squared, which is 1. Add my like terms. 2x squared, simplify 1 squared into 1. To solve for x, I'm going to divide by 2 and get a half. And then I come in and do the square root on both sides. I can break that up. What I'm going to end up getting is that x is equal to, keep in mind it will be plus or minus depending on which quadrant I'm in. Square root of 1 is 1. Square root of 2, I'm going to keep it because it's not exact, or this is exact. It would change to a decimal. Now in the radical world, this is not simplified. We cannot have radicals in the denominator of a fraction. So to get rid of it, you multiply by itself on the bottom and the top. It's an equally balanced option. What this gives us is now x is going to be equal to, again, plus or minus depending on the quadrant. 1 times the square root of 2 is this. Square root of 2 times the square root of 2 is the square root of 4, which is the number 2. So we just derived that the square root of 2 over 2 is the exact answer. The approximate answer is 0.707. So now what we know, going forward, if I ask you what is the cosine of 45 degrees, in the exact world you would have to say it is the square root of 2 over 2. And we know because at 45 degrees the sine and cosine are equal, I know the sine of 45 degrees is also the square root of 2 over 2. So let's look at 30 degrees. Now, we know when we draw a ray and when it crosses the unit circle, it actually hits for 30 degrees at approximately 0.866 and then 0.5. Now, 0.5 we can actually convert to an exact value quite easily in a fraction format that's the same as 1/2. So we actually know that length. And I'm going to sketch that in. This side length is 1/2. The question is, what is the x side length? Well, we can find the side length for x, again, by just using Pythagorean's theorem. 0.866 is approximate. That is not sufficient enough. So let's do Pythagorean's theorem and do a squared plus b squared equals c squared. I'm going to have a be this x, so that'll be a. So we are b and c. And let's do that. So x squared plus 1/2 squared equals 1 squared. Simplify this, x squared plus 1/4 equals 1. Subtract 1/4 from both sides, x squared equals 3/4. Take the square root of both sides, can do this. And what we're going to get is x is equal to, again, plus or minus, depending on the quadrant, the square root of 3 over 2. So what I just did is I figured this out. Since the x movement is cosine, I know the cosine of 30 degrees is equal to exactly the square root of 3 over 2, and the sine of 30 degrees is equal to 1/2. And those are the exact values. Now, if we look at 60 degrees, this one's actually has a nice trick to it. The 30 degrees is already drawn in there. Let's draw in the 60. This is a 60-degree movement. Now, just make the connection. We just derived in the last slide that the ordered pair here is the square root of 3 over 2 and 1/2. Now, the angles 30 and 60. From section 4.3, 30 and 60 are complements. Therefore, I can apply the Compliments Theorem, which just says the ordered pairs just swap out and they change their position. So this is actually quite easy. 60 degrees, by the way, how many radians is that? It is 1/3 of a pi. 1/3 of a pi would be 180 over 3 or 60 degrees. And what I can say this is that the cosine of 60 degrees is going to be 1/2. And the sine of 60 degrees is the square root of 3 over 2. Now, if you look back at this table we did earlier in Chapter 4, these are the approximate values. You're going to notice again that there's a pattern. Here's Quadrant 1, right? Then we go over into Quadrant 2, and Quadrant 3 and Quadrant 4. What we're going to want to do now is get away from the approximate unit circle and go to the exact unit circle. So I'm going to freeze the video here for a second and fill in Quadrant 1, and then you can see for yourself what it is. Go ahead if you'd like, pause the video, and then start it up and see if you can fill in the exact values for Quadrant 1 exactly. This is what Quadrant 1 looks like as the exact unit circle. Now, you are going to have to memorize Quadrant 1. In pre-calculus, you have to memorize the entire unit circle. I'm going to give you an extra credit opportunity to memorize the entire unit circle. Let's look at some connections really quick. If you look at this, you're going to notice all three of these are all divided by 2. They're all by halves. And if it helps you, just think of it this. It goes 3, 2, 1. You can do the square root of 3, the square root of 2, and the square root of 1, which is just the number 1. That might be a nice way to make the connection. Now, the only difference, again, I'm going to pause the video and fill in the next quadrant, is that the signs change. Okay, Quadrant 2 looks like this. Again, we're going to have the same connection. Folks, you do not have to memorize every quadrant. If you can memorize Quadrant 1, you just need to think about how this stuff moves around the unit circle. The one quadrant is going to have the exact same numbers of the other. The signs change as you move left and right versus up and down. Now, what you really want to do to wrap up this activity is to take this unit circle, and I'm going to give you an extra credit opportunity, which what you would have to do is give me 4 things. You're going to have to draw in the angle, state the degree, state the radian, and tell me the ordered pair at which this happens. So the cosine of 0 degrees is 1, the sine is 0, so it's the ordered pair 1, 0. For example, when 30 degrees comes up, draw 30 degrees. That's the same as pi over 6. The exact value of this is the square root of 3 over 2. That's the cosine of 30. The sine of 30 is 1/2. Again, doing the same for 45 degrees. The nice thing about 45 degrees, it's an isosceles triangle. So it's square root of 2 over 2 and square root of 2 over 2. The 60 degrees is just the complement of the 30. So this is going to be 1/2. And then the square root of 3 over 2. And then the last one for a full kind of quarter circle, 90 degrees is the same as pi over 2, and it's the ordered pair of 0, 1. By the way, folks, 90 degrees and 0 degrees are complements of each other. Their ordered pairs are just flipped. I suggest that you complete this unit circle for yourself. You are required to know all of Quadrant 1, just what's listed here. Again, the degrees, the radians, and then the ordered pair, which gives me both the cosine and the sine of that radian or angle movement. When you have the extra credit opportunity, again, everyone is going to have to fill in the Quadrant 1 of here. I expect you to draw the angle. Put here for me that it's 30 degrees, pi over 6, square root of 3 over 2, and 1/2 is an ordered pair. For extra credit, what you'll do is fill in the rest of these with all that information. This is a great page to practice on if you want to see if you can do it. And I'll give you more details in class and when we'll do the extra credit opportunity. Now the second part of section 4.4 is a separate video, more of the official notes on how to use the exact unit circle to answer mathematical questions. So go ahead and take a listen to the next video.